Hi kids. We're going to do a problem. It's Joe is sliding a 40 kilogram box down a 20-degree incline with a helium balloon attached to it. Who knows? Could happen. If the balloon exerts a force of 8 newtons and mu, the coefficient of friction, is 0.1, I want to determine the acceleration of the box down the incline. So, gee, I don't know where to start. Let's start with the free body diagram. Alright, I recommend make your diagram big. So I'm going to fill up this whole board here, which means I may have to erase the problem later when we do our actual equation. So I'm going to make our free body diagram big. Again, I recommend you do this because if you make your free body diagram big, it's going to be easy to see the different forces. So there's my incline. Okay, there's my box that's sliding down the incline. If we do the forces that are acting on my box, I'm going to have the force of gravity straight down. I am going to have the force of friction because it is sliding down the incline. My force of friction is going to go parallel and up the incline. I am going to then also have the balloon. Now remember, a balloon is going to pull straight up on something, so the force applied from my balloon is going to be going straight up. So there is my force applied from the balloon. And that is my free body diagram. Now guys, be careful. Will every free body diagram look like this? Absolutely not. Okay, you have to look at the problem and then draw your forces according to the problem. But if you notice, there's two forces here that are not directly parallel to the incline or perpendicular to the incline. Oops, I forgot what force. You're right, I forgot my other perpendicular force, which is the normal force. So I'm going to draw the normal force. There's my Fn. Okay, so sorry. Now my free body diagram is complete. And there are two forces here that are not directly parallel or perpendicular, which is Fg and my applied force from the balloon. That means I have to break those two forces down into their components. And again, I would recommend you use different colors. I'll use different colors for each one. My Fg is going to be, here is Fg parallel, and here is Fg perpendicular. Be careful, make sure that that's your right angle. If that's your right angle, my 20 degrees is in that top thing right there. For my FA, here is FA perpendicular, and here is my FA, again, there's my right angle, there's my FA parallel. Okay, again, if you look, this angle here has to be my 20 degrees. Be careful, guys. FA perpendicular and Fn are different. That's why I drew them in different with different colors. Okay, so we got our first step there. Our next step is we want to write our two equations. We're going to write Fnet parallel and then Fnet perpendicular. Again, I'm going to try to do it here. If I don't have enough room, I'm going to actually, you know what? I'm just going to erase my problem and we'll do it over here. So just remember, the balloon exerts a force of 8 newtons and mu is 0.1. Okay, I'm back, and if you look, I just wrote down my important givens here, so that now if we set up our Fnet parallel, okay, for my Fnet parallel, I want all my parallel forces. I have Fg parallel, Ff, and Fa parallel. So I'm going to guess, and again, if we guess wrong, we'll be able to determine at the end, but I'm going to guess that Fg parallel is bigger than those two, so I'm going to get Fg parallel minus the quantity F of F plus Fa parallel. Everybody good there? And I'm going to set that equal to Ma, so I get Ma parallel equals Fg parallel minus Ff plus Fa parallel. Okay, and there's my parallel equation. I'm going to do my perpendicular equation over here just so that we can separate them. And for my perpendicular side, I have Fg perpendicular, Fa perpendicular, and Fn. So my Fnet perpendicular is going to be Fa perpendicular plus Fn minus FG perpendicular. I'm going to set that equal to MA. But again, this is parallel, this is perpendicular. Everybody good there? Now if you look, this is always 0 because it is not, it's accelerating along the incline, not perpendicular to the incline. So this is going to be 0. And now I want to start plugging in numbers. Okay, for FG parallel, okay, if I plug in numbers here, actually, you know what? I'm going to plug in numbers down here first because I need the normal force in order to solve for my force of friction. So if I solve for my normal force, or if I use this equation first, FA perpendicular, well, we know FA was 8, so the perpendicular is going to be, it's going to be 8 times the cosine of 20. And hopefully that makes sense if you look up here. And then plus Fn minus my FG, which is going to be 40 times 9.8 times the cosine of 20. And if we do some math, I can solve for f of n. So let me do some real quick math here. 8 times cosine of 20. And then I got 40 times 9.8 times cosine of 20 minus that answer. And I get 360.8 newtons. That's my normal force. Okay? And again, I need my normal force because that's going to help me with my force of friction. Remember, the formula for friction is mu times the normal force. Okay, so if I plug in numbers that I know over here, my mass is 40. I'm looking for my acceleration. My FG parallel is going to be 40 times 9.8 times the sine of 20. Hopefully that makes sense. Minus the whole quantity. Now for my f of f, it's going to be 360.8 times 0.1, because it's mu times the normal force. So it's 0.1 times 360.8 plus, and now for my FA parallel, it's going to be 8 times the sine of 20. So it's 8 times the sine of 20 degrees. Okay, hopefully that all makes sense. If I plug in some numbers, I'm going to get 40A equals, let's just do some math here. So this is 134.1 Newton minus, I should put parentheses around this whole thing, 0.1 times, so actually I can do that in my head, so minus the quantity 36.08 plus 8 times sine of 20, 2.7. And if I do the math here, I'm going to get 40A parallel equals 134.1 minus the quantity 36.08 plus 2.7. And I get 95.32. And A then is going to be equal to 2.38 meters per second squared. Now, as far as direction, because again, acceleration is a vector, I got a positive value. That means up here I guessed correctly. That means that FG parallel is bigger. That means it's accelerating down the incline. So my acceleration is going like this. So if it's moving this way, accelerating that way, it means it is speeding up. And wow, what fun. We get to add everything together. Have fun. Bye. Bye, kids.